Let's look at how to simplify irrational square roots. So quick reminder of what irrational means. So this is where you have your non-terminating, non-repeating decimals. Things like square root of 7, all right? If you had something like the square root of 4, that fits over here in natural, and I would expect you already to know that that's 2. Okay, so we're focusing today here on this category. So some vocabulary reminders. The square root sign is known as a radical. Because we don't only have square roots, we have cube roots, fourth roots, and fifth roots. The value beneath the radical sign is known as the radicand. So let's look at some rational square roots. Square root of 25 is equal to 5 because, remember that 5 squared is equal to 25. So if we unsquare this, we're left with just 5. Okay, the next one, the negative root of 121, this is telling you they want the negative root, which is 11, negative 11. When you see plus or minus in front of it, technically remember there's always 2 square roots, so they're telling you that they want both answers. So this is plus or minus 14. I would encourage you to have your roots up through 15 memorized. So let's look at irrational square roots, and I'm going to show you 2 quick methods. In earlier grades, you may have looked at making a factor tree where you break down your radicand down to primes. So since you have a pair of 3's, you can take the square root of 3 squared. So it comes out as 3, but you don't know the square root of 2. It's irrational. It's 3 root 2. Okay, so that's one way. A second method would be to, if you have good number sense, if you know that root 18 is equal to 9 times 2, meaning you know your perfect squares, and the square root of 9 would be 3, and you don't know the square root of 2, it's irrational, so that's 3 root 2. So you pick which method you like best and that you're fastest at. I will show you one more both ways, so make a factor tree. So once I have it broken down to a product of primes, I look for pairs. I have a pair of 2, so it comes out, I can take the square root of that, it would be 2. I have another pair of 3's on the outside. What I don't know would be the remaining 2 times 3, so I just put that back underneath the 6, so this would be 6 root 6. Something that's a good idea is to type this into the calculator as well as this and make sure that the decimal approximation is the same. Now, your second method would be, if you're really good with mental math, or even if you're not, you pick up your calculator and you start testing some of your perfect squares. You see if 4 goes into it. If 4 does, try something bigger. Try 9. Well, if both 4 and 9 go into it, try 36. 36 is a perfect square, and it goes into it 6 times. 36 times 6. And then you know the square root of 36. It comes out as 6, and the other 6 stays beneath the radical sign. Okay, so you try whichever method you prefer. Your goal is to get quick because you're going to do this a lot with quadratics. For these next 2, try them on your own. Hit pause, check it when you're finished. For 6, I know that 25 is a perfect square that goes into it, so it comes out as 3 times 5 root 3 for a final answer of 15 root 3. And here's the answer to 7. In 8, I need to remind you how to multiply radicals together. So this has a coefficient of 1, the second radical. What you do is you multiply your coefficients together, so 4 times 1, and you multiply your radicals together as long as they're both square roots. And that would be 36, and 4 times root 36 would be 4 times 6, which is 24. In this one, we're going to simplify this expression. So 15 minus root 18. First of all, I can break down root 18, and I actually already did that. 9 goes into it, so it's going to be 3 root 2. I'm going to recopy the first part over 6. And what I do from this point, there's really 2 ways I can do this. I'm looking to see if there's anything that goes into 6, 3, and 15, all 3 of them. Okay, so 3 goes into all 3 of those values, so I'm going to reduce it to, if I divide each by 3, I would get 5, I'd get 1, and I would get 2 down here. So my answer can be expressed as 5 minus 1 times root 2 would just be root 2 all over 2. Okay? So you can leave it like this. Just to show you a different acceptable way would be to write 5 over 2 minus 1/2 root 2 like this would be acceptable. But this one here is probably more common. Now I'm telling you to evaluate it to the nearest hundredth just because I want you to actually pause and practice entering this into your calculator. And the trick is just to make sure that you get your parentheses in the right place. So you need to make sure your entire numerator is in parentheses. Now, if you have an older TI-83, they open up a set of parentheses here, and then you have to close it, so you end up having a double parentheses. So just pay attention. If you don't have the entire numerator in parentheses, you will get a wrong answer. Okay, now the nitty-gritty. In mathematics, it is not considered simplified if you have a square root down in the denominator, so we need to get rid of it. And the trick is to multiply. If it's just a regular square root, you multiply by a disguised form of 1, where the top and bottom would both be the root. If you have a sum or a difference, we're going to use something known as the conjugate. So I will illustrate that with an example. So I look at this one, 8 over square root 3. Looks okay, can't break down 8, can't break down 3. Make sure you don't try to simplify ever anything that's outside of a radical and something that is inside of a radical. So my trick here to rationalize the denominator is to multiply both the top and bottom by root 3. So on the top, I get 8 root 3. On the bottom, I would have root 9, which just produces 3. So a lot of times kids will bypass this middle step, and that's fine as long as you understand where it's coming from. Nothing here reduces. You should always check these two coefficients, the 8 and the 3, never the one under the square root sign, the radicand. Now let's look at one where I have a sum in the bottom. So the trick here is to multiply the top and the bottom, of course, by the same thing because it's a disguised form of 1, but we're going to multiply by the conjugate, which is just flip that middle sign from a plus to a minus, okay? Numerator is pretty easy. 1 times that is just 5 minus root 6, okay? Denominator, what you're really doing here is you're multiplying two binomials together, so you need to distribute, or first add or inner last. So I'm going to distribute this 5 to get 25 minus 5 root 6. Then I'm going to distribute the second root 6 to get plus 5 root 6 minus root 6 times root 6 would be root 36, which is just 6. Now, you should see that these two middle terms here drop out. So what I really have is 25 minus 6 on the bottom, which is 19. The whole purpose of why I needed to rationalize that denominator, it's now gone. Now again, you should check and see, does the 5 and the 19 and the coefficient here, which is 1, reduce? Nope, it doesn't, so there's your answer. It's your turn to try this one. One little hint is first use the quotient property, which says you can separate it into two separate radicals like that to get going. Here's my answer. Notice that I simplified root 18 first to 3 root 2. It just prevents my numbers from getting bigger. I could have done it at the end, just make sure you do it along some point. Okay, as always, please reach out if you have any questions.